Unbalanced transportation problems. Until now, we have discussed the balanced type of transportation problem where the total supply equals to total demand, that is summation AI equals to summation Bj. But sometimes in practical situations, supply may be greater than demand or demand may be greater than supply, that is supply and demands are not equal. These situations are known as unbalanced transportation problems. Thus, if in a transportation problem total supply is not equal to total demand, that is summation AI, I running from 1 to m not equals to summation Bj, j running from 1 to n, then such a problem is called unbalanced transportation problems. So, first case is summation AI is greater equal summation Bj. The dummy destination column in the given transportation problem is introduced. The unit transportation cost to this dummy destination column are all set equal to 0. The requirement at this dummy destination column is assumed to be equal to summation AI minus summation Bj. So for example, this is destination source required Bj and this is capacities AI. So here if we calculate total capacity and total requirement, both are not equal. So total capacity equals to, if we calculate that, so total capacity is 8 plus 12 plus 14, 34, and requirement 4 plus 4 plus 6 plus 8 plus 8. This is dummy. So here requirement is 30 total. So summation AI minus summation Bj, 34 minus 30, that is 4. So we add the column with cost or value of B6 is 4 with is dummy column. So we add this dummy column. If summation AI which is less equal summation Bj, the dummy source row in the given transportation problem is introduced. The unit transportation cost to this dummy source row are all set equal to 0. So all equal to 0. The availability at this dummy source row is assumed to be equal to summation Bj minus summation AI. So here example, destination source requirement availability. So here total availability is 800 plus 500 plus 900, which is equals to 2200, and requirement 400 plus 400 plus 500 plus 400 plus 800, which is equals to 2500. So there is lack of 300 units in the availability. So we add the dummy row with all the terms 0 and availability is 300. So here our total availability is equal to 2500 and total requirement also equals to 2500. So this is so total availability equals to total requirement. So the transportation problem is balanced transportation problem. Now see the example. Find the initial basic feasible solution of the following transportation problem and obtain the optimal solution by using MODI method. Here the example is given where total capacity is 34 and total requirements are 30. So for balancing, add a column destination D6. Here 30, so requirement is less, so we add the dummy column with cost 4. So here we add the dummy column D6. So here total capacity is 34 and requirement is also 34. Therefore, the transportation problem is balanced transportation problem. So by using Oja's approximation method, that is SWAM, the initial feasible solution is obtained, which is given in the table. So by Oja's approximation method, we get these allocations. So the total allocations are 1, 2, 3, 4, 5, 6, 7. So from these allocations, the total transportation cost is rupees 80. So for optimality test by Modi method, here the total number of allocations is 7, which is not equals to m plus n minus 1. M plus n minus 1. So here m is 1, 2, 3 plus n is 6. 3 plus 6, 9 minus 1 is 8. So here allocations are not equals to m plus n minus 1. The solution that we obtain is degenerate basic feasible solution. So in the last video we see how to solve the degeneracy in the transportation problem. So we allocate here epsilon to the cell 1, 1. We have the following table. So we add this epsilon to this 1, 1 position. So we find by Modi method ui and vj. For occupied cells, we use ui plus vj equals to cij and u1 equals to 0. So for these occupied cells, we get u1, u2, u3, v1, v2, v3, v4, v5, v6. Now we calculate dij. For unoccupied cells, we use dij equals to cij minus ui plus vj. Now so from this formula we get d131, d155, d162, d211, d222, d233, d262, d322, d343, d350. Since all the dij greater equal 0, the solution under test is optimal and at least one, that is d35, which is equals to 0, indicates that alternative solution will also exist.